This is video 5. We are going to look at two tangents from a common point to 2 points on a circle are the same length. So let's have a go at showing you what this looks like. Okay, so here you can see I have two tangents. So this line here, if that line AB were to extend all the way, and this line here, AC. So you can see they're tangents because there's a 90-degree angle there, and they meet at point A. And you can see if I move point A around, you might be able to spot that the distance from AB is the same as the distance AC. And you can see that they stay the same. You can also, now the proof might kind of be obvious once I've shown you these dashes that show the lengths properly. So the name of this is tangents to a point are of equal length. That's just how you can summarize it in an exam. If you're asked to say what rule is this, that is good enough to get the marks. So let's prove where it comes from. So first of all, we know that these two lengths here, because they're radii, they are the same length, so we can just label them with a dash. And then you can also say that these two angles have to be 90 degrees because they're a tangent. So you're told it's a tangent, so you don't have to prove it's 90 degrees, it's just going to be 90 degrees. And you have to write that out. So OBA is 90, OCA is 90 degrees. Now that means if we draw a line from O to A, we can actually make two triangles, and they happen to be a special type of triangle. They are both right angle triangles, which means we can then use Pythagoras because OA is the hypotenuse of both triangles, and they also happen to match. They're a common side. So triangle OAB and OAC are right-hand triangles. So therefore, we can say that BA is equal to BC. And we can use Pythagoras to prove that if we need to. So we can, for example, label this length X, label this length Y, and then do X squared plus, we can call this AB squared is equal to Y squared. And then you can do the same thing for the triangle underneath, and you get, well, they're equal to each other. Therefore, the lengths are equal. So let's do some examples here. Okay, so pause the video now and have a go with both of these questions. Work out X, Y, and Z, and then I'll show the answers in a couple of seconds. Okay, so working through these questions together. For X, now we don't have to prove the theorems in this case, we're just using them. So we know that these two lengths have to match. That means that this angle has to be X, and to work out what X is, we just do 180 take away 44 divided by 2, and that will give me X equals 68 degrees. Now question 2, not as tricky as it looks. So first thing I know, as I'm going to label every angle that I can, I know that a tangent meets a radii or radius at 90 degrees. So those have to be labeled 90. That was the first bunch of properties I taught you in this series of videos. It's not a theorem, it's just a property. Now I know that if that's Y, well, this will have to be 2Y. And this here will have to be 360 take away 2Y because its angle's on a point. And we want to work out Y, we're about to work out what that angle is. So looking at this quadrilateral here, so this quadrilateral, which I'm just going to shade in for a second. So we're looking at this one here. It's a four-sided shape. So the inside angles have to add up to 360 because there's essentially just two triangles there. And I know that the things that are inside it are 90 plus 90. So those two angles, that's just going to be 180 plus A plus Y. Now we can just solve that. It's very straightforward. 360, take away 180, take away 148, divided by 2, and I get y is equal to, let's see, what did I do there? 180. I get 66 degrees is y. So let's just label that carefully now. So this is going to be 66 degrees. That means that this angle here is going to be 66 times 2, which is 132 degrees. And now we need to find z. So we're now just going to look at this quadrilateral here. So I can work out this angle by doing 360 take away 132. So this is going to be 228. And then the last bit, looking at that quadrilateral, is going to be 360, because the angles inside add up to 360, because it's just two triangles, really. So let's just rub that one out. 360 is equal to 66 plus 228 plus 40. When you rearrange that with z equals 26 degrees. So those are your answers. Okay, so I'll see you on the next video for the next proof.